There are monsters out in the cosmos that can swallow entire stars and that can destroy space itself. Black holes. For decades, they remained completely hidden. But now, quantum physicists are entering into their uncharted territories. They have discovered that black holes don't just rule the realm of the stars and of the galaxies, but in fact, they can impact all of us right here at home on the planet Earth. Because black holes just might be the key to having and understanding the elusive quantum epiphany that we are all searching for as we strive to understand what having the knowledge of the quantum physics of reality is all about. My name is Todd Lindgren, and I am the host and the author of Quantum Epiphany, the quantum physics of reality. I welcome you all to join me in our weekly program that's filled with fun facts and incredible stories, as well as amazing lessons that are taught to us by the brightest scientists and the brightest quantum physicists that the world has ever known. As you will soon find out, many of these great men have come to the universal conclusion that reality is not at all as real or as solid as we all have truly believed that it really is. If you took the planet Earth, for example, and you squeezed it down to the size of this cue ball on a billiards table, you would create an object that is so dense that not even light traveling at 186,000 miles per second could escape its extraordinary gravitational pull. Its name is a black hole. Quantum physicists think that black holes form when giant stars run out of fuel and they collapse underneath their own weight. But they're not really sure. Why? Well, it's because black holes are places where the accepted laws of physics actually completely break down. Now, there's a few bold thinkers, actually there's many, but a few that we are going to be hearing from right now, like Dr. Leonard Susskind, Dr. Brian Greene, and Dr. Clifford Johnson, are making giant strides towards understanding what really goes on inside of black holes, and the new physics that have emerged have had stunning new implications. What they have learned, as you will now see, is that you, me, and the entire world that we now live in may be nothing more than just an illusion of reality, and that anything real at all, like we have actually believed all of our lives to be the truth.
Modern ideas coming from black holes tell us that reality is two-dimensional, that the three-dimensional world, the full-bodied three-dimensional world, is a kind of image of a hologram on the boundary of the region of space.
This is a very strange thing. When I was a younger physicist, I would have thought any physicist who said that was absolutely crazy.
Here's a way to think about this. Imagine I took my wallet and threw it into a black hole. What would happen? We used to think that since nothing, not even light, can escape the immense gravity of a black hole, my wallet would be lost forever. But it now seems that may not be the whole story. Recently, scientists exploring the math describing black holes made a curious discovery. Even as my wallet disappears into the black hole, a copy of all the information it contains seems to get smeared out and stored on the surface of the black hole, in much the same way that information is stored in a computer. So, in the end, my wallet exists in two places. There's a three-dimensional version that's lost forever inside the black hole, and a two-dimensional version that remains on the surface as information.
The information content of all the stuff that fell into that black hole can be expressed entirely in terms of just the outside of the black hole. The idea then is that you can capture what's going on inside the black hole by referring only to the outside.
And in theory, I could use the information on the outside of the black hole to reconstruct my wallet. And here's the truly mind-blowing part. Space within a black hole plays by the same rules as space outside a black hole or anywhere else. So if an object inside a black hole can be described by information on the black hole surface, then it might be that everything in the universe, from galaxies and stars to you and me, even space itself, is just a projection of information stored on some distant two-dimensional surface that surrounds us. In other words, what we experience as reality may be something like a hologram.
Is the three-dimensional world an illusion in the same sense that a hologram is an illusion? Perhaps. I'm inclined to think yes, that the three-dimensional world is a kind of illusion, and that the ultimate precise reality is the two-dimensional reality at the surface of the universe.
Lurking at the center of our galaxy is an object that is completely invisible. But at the same time, it weighs as much as 4 million stars combined. 4 million stars. Astronomers now believe that almost every single galaxy in the entire universe, which is billions of galaxies, have supermassive black holes at their very core. So, if there's billions of galaxies in our universe that have supermassive black holes at their core, creating their universe, creating their galaxies, I think it's kind of important for us to know what is really a supermassive black hole. How's it created? What is it? Science fiction says that black holes are cosmic time machines or portals into a parallel universe. But real scientists and real quantum physicists that study this every single day are finding that truth is actually much stranger than science fiction ever could possibly be. You are about to enter, with me, through Quantum Epiphany, into the world where the very big and the very small are completely indistinguishable. Into a world, a quantum physics of reality world, where reality and the illusion of reality are exactly one and the same. And that is a quantum epiphany. You see, the scientific visionary Albert Einstein saw space and time as a flexible material that could be distorted by gravity. What he found out, and what has been later unproven time and time again and again and again by quantum physicists and scientists the world over, is that a black hole is merely a very deep well within this material, as Einstein actually called it. So, you see, when two black holes become intertwined and close to one another, these two orbiting wells of material stir up both time and space, and they send out ripples that can travel clear across the entire universe. And when these ripples or these waves move out through the universe, and they travel at actually 186,000 miles per second, which is the speed of light. And when this happens, we can hope to see black holes. Not through our eyes, because obviously black holes are black and they're invisible. But we can see black holes through our other senses, through our ears, for example. As we can pick up, using incredible scientific equipment, the wobble in the fabric of space-time itself, which is something that scientists are now calling gravitational waves.
It's the discovery of a lifetime. Physicists have spotted gravitational waves churned up by two black holes locked in a death spiral deep in space. No one has seen such waves before, and they're about to open new eyes on the cosmos. Until now, scientists have learned about the universe mainly by studying light and other electromagnetic waves from space. But gravitational waves are ripples in space itself. They are set off by stellar cataclysms, such as massive neutron stars or black holes whirling together. To sense the waves, physicists use massive L-shaped optical devices called interferometers. Each arm of the L is 4 kilometers long. There are 2 of these devices in the United States, and together they make up LIGO. To detect the stretching of space, LIGO uses laser light to measure and compare the lengths of the 2 arms. When a gravitational wave ripples past, it will stretch the arms by different amounts, causing the light to warble out of the interferometer. The measurements are sensitive, to within 1/10,000th of the width of a proton. Physicists hope to use the waves to test Albert Einstein's theory of gravity, and also to detect strange objects that until now were completely invisible. Take the signal that LIGO detected. The black holes responsible are 3 times as massive as normal, and nobody knows why. It's just the first surprise from what promises to be a whole new type of astronomy.
Thank you guys for all joining us here in Season 1, Episode 1 of Quantum Physics, the quantum physics of reality. In this episode about black holes. Our next episode starts off where this episode leaves us, which is with the incredible discovery of something called gravitational waves. And we hope to see you all there. This is Quantum Epiphany, the quantum physics of reality. And my name is Todd Linger, and I am your host of Quantum Epiphany. And thank you for joining us.